And when a federated building model fails to load, the crash usually happens at the worst possible moment. Teams attempt to exploit their information model for schedule sequencing or cost estimation, only to watch the software buckle under the computational weight of the file. This instability often stems from a professional misconception that treats building information modeling primarily as an exercise in high-resolution 3D geometry. Moving a project into higher dimensions does not require a linear scaling of polygon counts. Modeling every physical screw, every small connection flange, and structural hanger creates a level of detail that eventually strangles the system. To execute multi-dimensional virtual design and construction, project teams must shift the focus from visual fidelity to the underlying data structure of the digital asset. This breakdown reveals the two distinct data types comprising a digital BIM asset. On the left, geometric attributes defining physical space, exact size, and volume. On the right, non-geometric attributes. These parameters define behavior, housing system performance, and compliance data. As a project moves through its lifecycle, these two datasets scale at different rates. Strictly separating a model's physical space from its behavioral identity is a mandatory step in building a resilient, federated model. The industry uses the level of development, or LOD framework, to track how this information density increases as a project progresses. At LOD 300, the focus is on measurable spatial accuracy. The element is modeled as a specific object in terms of quantity, size, and location. Advancing to LOD 350 requires modeling the parts necessary for coordination with nearby systems, such as physical supports and connection interfaces. While LOD 350 adds minor geometric parts, the primary requirement at this stage is non-geometric density. The model must now host parameters for live loads, clearance requirements, and material specifications to remain useful for the next phase. Advancing a model's LOD is an exercise in data enrichment rather than a push for geometric photorealism. To protect computational performance, BIM managers use a technique called strategic omission, the decision to keep certain elements out of the 3D space. Modeling every ceiling subframe or hanger causes federated models to become too large and unmanageable. Many projects establish a size threshold. Physical elements smaller than 100 millimeters generally do not need to be modeled in 3D. Instead, 2D standard details and manual counting parameters are used to complement the model for these omitted elements. This strategy extends to simplifying architectural ramps as simple floor elements and relying on typical details for railing profiles. Omitting specific geometries is not a shortcut. It is a structural requirement for a functional BIM environment. This lean approach is essential for higher dimension VDC, specifically 4D scheduling and 5D cost estimation. It is a common misconception that upgrading a model to 4D or 5D requires any visual or geometric changes to the assets. 4D scheduling is the process of linking temporal parameters to the existing geometry. The 3D shape remains unchanged, but it now carries non-geometric time attributes: installation date, lead time, and sequencing phase. 5D cost estimation works the same way, pulling non-geometric financial text data from the asset. The ledger extracts the unit cost, labor rate, and material code directly from the object's metadata. These additional dimensions are entirely about parameter integration, decoupled from geometric resolution. How do cross-disciplinary teams agree on the exact balance between model geometry and text data? The BIM Execution Plan, or BEP, acts as the contractual governor of the project's data architecture. It defines which elements require 3D modeling for spatial coordination and which only require non-geometric parameter tags. Without a strict BEP, individual teams often default to their own modeling standards, leading directly back to the over-modeling trap. The BEP is the central source of truth that protects the technical viability of the model. A superior BIM asset does not necessarily mean a visually denser 3D model. The goal is to build digital assets that maintain a strict cap on geometric complexity while carrying the high parameter density required for analysis. Rigorously managing this boundary provides the technical headroom necessary for federated models to handle complex 4D scheduling and 5D cost integrations without system failure. Mastery of VDC does not come from modeling everything, but from knowing exactly what